TI's Demystifying Surge Protection series. As we discussed in the last few videos, TVS diodes have inherent limitations and drawbacks that prevent them from providing the ideal protection stage. This video will discuss an alternative to traditional TVS diodes, TI's flat clamp family of surge protection devices, for applications that need more precise protection than traditional TVS diodes can provide. You can learn more about our flat clamp devices by clicking the link below. While traditional diodes are fundamentally little more than a diode junction, TI flat clamp diodes provide surge protection through a new topology that integrates a power MOSFET driven by a gate driver and a feedback loop. During a surge event, the MOSFET is turned on to shunt fault current and emulate a TVS diode. However, in addition, the feedback loop regulates the line voltage far more precisely than a traditional diode is capable of. This means that the flat clamp devices have a small, almost zero, dynamic resistance that leads to very low clamping voltages. Due to the low clamping voltages, designers have the ability to significantly shrink margin between system operating voltage and IC input voltage tolerance. As an example of this, let's look at the surge response of the flat clamp TVS 3300. Because of the very low dynamic resistance, the device has a flat response to the surge current. Compare this to a conventional SMA J33A TVS diode, where the high dynamic resistance causes a poor clamping response. This means that a designer using the TVS 3300 needs to have input absolute maximums above only 37 volts, requiring little margin and allowing the use of ICs with 40 volt tolerance. In contrast, a designer using the SMA J33A needs to include much more margin and use ICs with at least 50 volt tolerance. The simplified system requirements with the TVS 3300 often lead to improved design flexibility and cost savings. In addition to the lower clamping voltages, the flat clamp topology allows for lower leakage currents and capacitances. As discussed in previous videos, conventional TVS diode structures can have large parasitic elements, whereas flat clamp devices have nanoamp level leakage currents and very low capacitances, including over temperature. This means that for systems that cannot accept the distortion added by a conventional TVS diode, flat clamp devices offer a better protection scheme. The flat clamp topology also allows for smaller sizes and higher reliability. Compare the TVS 3300 WCSP package with a traditional SMA J33A TVS diode, where the flat clamp device is 10% the size. For space-critical systems, this can be a very helpful footprint saving. Finally, flat clamp devices also see better variation over temperature that leads to higher reliability. Compared to traditional TVS diodes, flat clamp devices see minimal derating up to 125 degrees Celsius. Each flat clamp device is also tested with 5,000 repetitive surge pulses at 125 degrees Celsius to ensure reliable operation. TI flat clamp devices offer a better way to protect systems from surge than traditional TVS diodes, taking away the drawbacks where precise clamping is a requirement. This is just a quick introduction to the devices. For a more detailed view, please reference TI's flat clamp surge protection technology for efficient system protection white paper. This document can be easily found at the link below. Thank you for watching TI's Demystifying Surge Protection video series. Next time you're faced with a surge protection challenge, remember these lessons to ensure reliable system protection.